All right, the last partial fraction example, this one takes into account just about all of it. So we look at this and we see that we have x cubed and x cubed. That doesn't work. We need to do some long division here to get it. So we have a lower degree in the numerator. So we have x cubed plus 6x squared plus 3x plus 16. So this is missing a bunch of terms, but the last one is a constant. So we're going to say it goes in once. We'd put that over the 16, the constant, and we get x cubed plus 4x. Let's go ahead and subtract this. So we get 0 there. We get 6x squared minus x plus 16. That degree is less than the original, so we're done with that. This is the same as 1 plus 6x squared minus x plus 16 all over x cubed plus 4x. The one part's easy. Let's deal with our partial fractions here. 6x squared minus x minus 16. It's actually not the first thing we should do. We should look and see, can we just integrate this? Do we have the derivative of the denominator in the numerator? No, because that would be 3x squared plus 4x, or plus 4. And there's no way to multiply to get that. So we are going to factor this. In fact, I probably should just do that in this stage right here. Let's say x times x squared plus 4. So we'll say a linear factor, so it's a over x. And then we have bx plus c over the quadratic, because that can't be factored anymore, over integers. So let's clear all the fractions. We get 6x squared minus x plus 16 equals a times the quantity of x squared plus 4 plus bx plus c times x. So now we're going to use both techniques. We want to do whatever is convenient. In this case, if we let, and I want you to write it, x equals 0, then we get 16 equals, over here, that gives a 0. So we just have, plug in 0 there, and we get 4a. So that tells us a is 4, and we're done with that. Now, there's no convenient way to get rid of this one. So let's go and look at equating coefficients. So we'll say the coefficient of x squared, on the left side we have 6, and on the right side we have ax squared, and here we're going to have, after we multiply it out, a bx squared, so we have a plus b. Since we know a is 4, that tells us b is 2. So look at the coefficient of x. On the left side it's negative 1, and over here we have no x's in there, but we'll have a c on this one, so c is negative 1. Now we can plug all this stuff in. 1 plus 4x plus 2x over x squared, 2x minus 1 over x squared plus 4. Now when we look at this, this is not a nice form, and what we could do is have just written it immediately to say, let's break it up. Because when we break this up to 2x over x squared plus 4, that's really nice because now we have the derivative of the denominator in the numerator. So that's just an ln graph. Minus 1 over x squared plus 4, and then we have dx. These first ones are pretty straightforward. We have x plus ln of absolute value of x. Again, we have the derivative there, so it's going to be ln of absolute value of x squared plus 4. Now, we don't have this one, and this is not something that I memorize, but I should recognize the form of it. Let's come over here, and we have 1 over, what we want to do is recognize, where have we seen something like this, x squared plus a number? It's x squared plus 1, which is our inverse tan idea. So let's pull out the 4 here. We'll have a 1/4 x squared over 4 plus 1 dx, and then we can do a substitution. Let u equal x over 2, du is 1/2 dx. So when we substitute that in, we'll have 2 du, here will be our dx, over u squared plus 1, and then we have 1/4 times that. So go ahead and reduce that. So we have 1/2. So this is going to be equal to 1/2 the inverse tangent of u. Now, since I'm only doing this as side work, I'm going to come over here and I'll fill in the rest of it. So it would be 1/2 inverse tangent of, I need to know what u is, that's x over 2 plus c. Now, this is good, but you should realize that this absolute value isn't needed here, so let's go ahead and rewrite this to say we need it on the first one, we do not need it on the second one because that is always positive, minus 1/2 inverse tangent of x over 2 plus c, and that is it.